Hey there, everyone. Ryan Schul here. Welcome to my channel. This is all about data science, machine learning, artificial intelligence, and things such as this. So today I want to look at a project about how to analyze global happiness. I saw this data set a while back, and I thought of doing some type of work with this. I kind of brushed it off, but then it just came up on my radar recently, like a couple days ago. So I thought the timing was good. I want to go ahead and understand the data first and foremost, and then try to understand it's called a happiness score, which feature every column in a data frame or in a table in a database is also known as a feature. It could be a column or a feature. Which feature is going to have the most impact on the score of happiness? So the number one happiest country is Finland. This is the top 5 over here. We have GDP, social support, health, life expectancy, freedom to make choices, generosity, and perception of corruption. Okay, so these are the features that are going to have an impact on the score of happiness. And I want to see which feature has the most impact. That's what the whole analysis is about. So this is kind of a feel-good exercise, and it's fun to do. But there's actually several real legitimate purposes why we might want to do this too, and over and above just for something fun. So policy effectiveness and government accountability. I think these kind of topics play into this kind of project here. Economic development insights, social progress and equality for the citizens of these different countries, international benchmarking, mental health and well-being advocacy, and basically long-term strategic planning for the residents of these different countries, wherever they happen to live, okay? So I'm going to import the data from this data frame, import the data from this file, from this CSV file, and pop that into a data frame right here. And by the way, at the bottom of the notebook, I show you where you can get this data. So I found this just doing a Google search, actually, but I put the link in here. So if you go there, you can download this data for yourself and do the whole analysis all by yourself. And I will share this code with you, right? So you can copy and paste it into a Jupyter notebook and run it. So there's actually a few files in here. I took the most recent. This is 2019. It went back in time like 2018, 2017. There was 4 or 5 different files. I thought the most recent was the most relevant. So you can see everything is imported into a data frame here. Finland is the first happiest country. They're number 1 on the list. Netherlands is here. This rounds out the top 5. We can look over here and get some basic statistics about the data in this data frame. The mean happiness score is 5.4. Standard deviation is 1.1. Minimum is 2.8. Maximum is 7.769. So that's what we see over here for Finland. Okay, so that's Finland. So here's the data frame, and here's the description of the data frame. We're using dataframe.describe. Okay, that's how we get this view down here. So I want to go ahead and plot the data just to see visually what it looks like. Okay, I looked at this before. I saw United States down here. United States is number 19, right? So they just barely make it into the top 20. And you can see it's doing a little weird thing over here. They have Norway, Switzerland, Canada. Okay, so it looks like Norway, Switzerland, Canada, and it seems to show every third country. I think there's just too much information in the data frame and things are getting jammed up a little bit. The next one is Costa Rica after Canada. Costa Rica, you can see here. But actually, if we zoom in, we can see a lot more detail. So I'm going to zoom in and look for the United States. We should see it over here. Yep, there's the United States. So that, I believe, is number 19. And this is showing us the top 20, right? Oh, it shows us everything in the whole world, but everything is sorted in descending order of the happiest score down to the not so happy score. Okay. So the nice thing about these data frames, about these plotly charts is that it gives you the chance to zoom in to see those details. Because from this view, there's no United States whatsoever. If you zoom in, you can see it. I believe, maybe I have to zoom more. I think I missed it. Let me go back again. Go from Norway up to about 20, right? I think it's somewhere around here. Oh yeah, so overshot a little bit. So there's the United States right here. Anyways, plotly charts are great because they're dynamic, they're interactive, and you can zoom in and zoom out and get all kinds of details about your data. So this is very interesting and very compelling, right? It shows us just relative to all the countries in the whole world, the happiness scores of each one. So let's continue on and see what else we can do with this type of analysis. On the x-axis, I want to see GDP per capita, and then on the y-axis, the happiness score. So you can see a darker color has a lower health expectancy. Okay, so I'm measuring health life expectancy by the color, so we can kind of add another dimension. So we see 3 dimensions actually. 3-dimension charts are harder to work with, but they reveal a lot more information. So on the x-axis, we have GDP per capita. Happiness score, you can see on the y-axis over here, this is going to be Finland. They're the #1 happiest. And these guys down here are South Sudan. And the same thing is represented in this chart down here. You see South Sudan last. Finland, you can't see first because there's just too much going on. It's kind of like hidden away there. It's getting every 3rd record, but not every single one. And then the 3rd dimension here is going to be health life expectancy. And we set that as the color, right? So you can see based on health life expectancy, Finland is #1, and what was it? South Sudan, I think, was coming in last place. So that's pretty interesting too, right? But we still can't answer the question, which features actually have a statistical influence on the happiness score. So we have to keep going with this. So let me create a correlation matrix so we can see how well correlated each of these features are with each other. So here's the correlation right here, correlation matrix. Oh, actually, sorry. Dropping anything that doesn't have an overall rank or a country or region. Okay, so I want to get the ranking out of there. If you look closely, the ranks are the first column, right? The overall rank, that adds nothing to the analysis. We're not trying to do a correlation of an identifier or of a ranking. That makes no sense whatsoever. And we're dropping this right here because this is non-numeric, and we can't create a correlation matrix based on non-numeric data, okay? So we're looking just at the numeric features over here. And when I run everything, we'll have the heat map, okay? And this is going to be all of the correlations, and I'm going to create a small list here where I can add annotations and then display the annotations on the heat map, okay? So we can see on the right side here, correlation of 1.0 is light yellow, okay? And everything on the diagonal is always going to be correlated with itself. And negative correlation is going to have a darker color. So we go from +1 to -1. So we have a few small correlations, kind of negative over here, point -0.3, -0.05. But you can see most of these have a high correlation. So health and life expectancy is highly correlated to the happiness score. Freedom to make life choices has about 0.57 correlation, so it's fairly high. Really want to see over 0.7 to be considered statistically significant. So health, life expectancy, and social support, and GDP per capita all have a statistical positive correlation with happiness score, okay? So now we're getting more into the analysis, and this is starting to make a little more sense at this point. But still, we don't know which features have a causal effect on the happiness score. So I'm trying to predict, or I'm trying to figure out, like, what's the cause and effect here? If we do one thing, what's the outcome? If there's a cause, what's the effect? Okay, so an example would be like, you get sick and you take some medicine and you get better. So taking the medicine is the effect, and the cause, or getting better is the effect. Taking the medicine is the cause, right? So this cause, medicine, better is the effect. In the stock market, it can get pretty complicated really fast. Or in the United States overall economy, the whole economy, it's pretty complicated. But you could do another causal analysis, maybe to see what kind of impact changing the federal funds rate has on stock prices or housing prices or unemployment. There's all kinds of causal relationships that you can look at in different data sets, right? But just think of a cause and effect. You have an input and you have an output. So let me go ahead and run this. Okay, and we have a causal estimate value. So basically, this is holistically now, how decent is this model at its ability to make predictions or to show causal relationships, not really predictions, to show causal relationships between the input and the output, right? Between the cause and between the effect. That's what I want to look at here. So let me hit Control Enter to run this. We're going to look at an OLS example, ordinary least squares, and look at the R-squared. So the R-squared is fairly high here. We see almost 0.80. So 80% of the time, the model is going to make accurate predictions, okay? So again, these are the features we're looking at. So we have social support, okay? And that's a p-value of 0.00, and as a t-statistic greater than 1.96. So to be considered statistically significant, we want a high t over 1.96 and a low p less than 0.50. So you can check the box there. That one satisfies the condition. Here we have 3.5 and 0.001. So that is statistically significant on predicting happiness score. This is significant. It's over 1.96 and under 0.5. Freedom to make life choices. This is 3.8, but 0.0. So again, we're great there. It's statistically significant. This one is not, okay, because the t-value is 0.984. We want to see 1.96 to be significant. And the p-value has to be less than 0.05. This is greater. It's 0.32. And the same thing with perception of corruption. There's no statistical impact between corruption and happiness score. Okay, so this is helping us to make judgments into the future. If we want to make predictions, we're very trained and tested and fit this model. So the model is set up. It's learning pretty well. 80% of the time, it's making accurate predictions. It's still a little way to a couple ways we can improve the model and get this r-squared a little bit higher. This video is not about improving r-squareds, but in the real world, you probably want to, work with that a little bit. And there's ways to do that. I have other videos about that. I'm not going to get into it because I don't want this video to drag on for hours and hours, but it's a decent r-squared. We can live with that 0.8% of the time. 80% of the time, it's making accurate predictions, but the model obviously is not perfect. 20% of the time, it's going to make a mistake. Okay. So that's fine. That's all well and good. Let's look at an example over here of a country map. And we're going to use Plotly again. You'll see this in almost all my videos. I use Plotly. I'm sorry, a country map is later. So this is a 3D cluster map of the happiness based on 3 different criteria. So again, we have a 3-dimensional chart over here. So this kind of was like a 2-dimensional chart, but the 3rd dimension would be the color. Okay, so the color is health life expectancy. On the x-axis, we have GDP per capita and happiness score. This is another type of a 3D cluster map. We can see over here, purple is a lower or a different cluster. Okay, we have 3 different clusters here. I believe I put in 3. Yeah, 3 clusters. So now we're trying to cluster the data into 3 different buckets or 3 different bins using K-means. And based on the social support, the health life expectancy, and the generosity values in this data frame, we're going to predict which score which countries fall into. Okay, and you can see over here Somalia, Mozambique, Nigeria, Congo. So basically, in these 3 clusters, you'll see very similar types of social support, health life expectancy, and generosity. I can even increase that. There's a bunch of different ways to do this clustering exercises, and you can use a elbow chart to get the optimal number of clusters. I'm kind of like cutting a couple corners here, but I think it's fine. It doesn't matter that much. Okay, I just want to see basically which countries are going to be clustered together. So Somalia, and let's see, Somalia was actually cluster 5. These might be easier to see. Sometimes these 3D charts are a little bit hard to grab onto. 4 and 4. So Luxembourg and Singapore are going to be similar. I think that makes sense. Norway, that was like number 1, wasn't it? Right. So all these are up there in cluster 4. Ireland, Switzerland, Hong Kong. So all these countries are pretty similar in terms of social support, health life expectancy, and generosity. And if I take a step back and see what some of the other clusters are, and you can see Finland here, or Norway, I believe was a number 1. Right? Wasn't Norway? Oh, Finland was 1. Norway was 3. But you can see how these clusters work out, right? Like anything that has the same color and falls into the same cluster is going to have essentially like the same, I wouldn't say lifestyle, but the same happiness score, right? Because they all fall into these buckets. They're all substantially similar. Countries that are different are going to be falling into different buckets, and their happiness scores are just going to be kind of different, right, from the other groups. We're just trying to compartmentalize or segment these countries into different groups. Okay, so now here's my global map. So again, I'm using Plotly. I'm looking at the original features that were given to us in this data set, and we have 10 clusters over here. I'm saying this to 10, and I'm doing the happiness score again. So These countries down here that are dark have lower, happier scores. These have the higher scores. Okay, there's Canada. Finland was over here. Norway, Sweden, Finland, 7.769. So these are the happier. Iceland is over here. These are happier countries. Australia is pretty happy. So I like this visual just because very quickly and easily you can illustrate the point of which countries have a happier index score or happiness score, and then which ones have a lower happiness score. And you can see the lower ones are kind of concentrated in the middle of Africa here, and as you get to the northern countries over here, mostly happy, and Australia, I guess these guys are pretty content over here too. So we still haven't answered the question, right? I'm doing all this different analysis just to understand the data set and to make more intelligent decisions and draw insights from the data, so I know how to set up my my final analysis here. So this is a causal graph. So remember, we're looking at cause and effect. Let me run it so you can see what this thing is doing. So we're looking at cause and effect. What features are causing people to be happy? That's the question I'm trying to answer. Okay, so if I go back here, remember, we had a bunch of features that we're looking at the beginning. GDP, social support, health, life expectancy, freedom to make life choices, generosity, perception of corruption. So which of these are going to have a high statistical impact on score? That's what I want to know. So I did all this preliminary analysis to try to find out. So you can see the relationships here. Generosity has a direct impact on perception of corruption, but not freedom to make choices. And I think that makes sense. Like generosity and freedom to make choices really don't have any relationship. There is a direct relationship between freedom to make choices and social support, but not health, life expectancy, and GDP per capita. But GDP per capita has a direct link to social support and health, life expectancy, right? And an indirect relationship to these others. So they're all kind of interrelated, right? And they're all having an impact on the happiness score. So we have to do a little bit more digging to figure out exactly what that is, okay? So let me do another type of analysis. So you can see with the causal graph that all these are having a cause and effect on the happiness score, right? But I want to get more quantitative results out of this. I want to get some kind of numerical representation of what the strength of these relationships is and what's the true impact, right? So if we use this causal model, and it's coming from a library called DoWhy. So again, this is the cause and effect. Why is this happening? That's what we're trying to determine. We know what's happening. We know these features are having somewhat of an either direct or indirect impact. Some here are direct, some are indirect. They're all having an impact on the happiness of different people all around the world, right? But what is actually driving that? So we can see here social support has a direct impact on score. Score is short for happiness score. 7.9%, not 9%, 7.9. I'll explain in a minute how this works, okay? GDP per capita to score is 0.37, so it's a little bit lower. 0.67, that's a little bit higher, not as high as this. So that's health and life expectancy. Freedom to make life choices has an impact on happiness score, 3.05. This is the highest one here. Generosity has a 0.96 impact on happiness score, and then perception of corruption has a 0.497 impact on score. So what do these numbers really mean? The numbers that we see below represent the estimated causal effect, or the cause and effect of each individual treatment variable and the outcome variable, right? So the outcome is the happiness score, and treatment or the inputs are all the other features that you saw. So each number is the expected change in the happiness score. So for instance, 0.9645 is the highest result right here. So if you increase generosity score by a factor of 1, the impact on the happiness score would be 0.9645. So it's pretty close one-to-one effect. This has a much lower effect. This is only 0.37. So if you increase GDP per capita, the happiness score will only increase about 37%, right? So that basically confirms the old theory, money can't buy happiness, right? If you increase the GDP, people are a little bit more happy, but not substantially happier. If people are just more generous to each other, it has almost a one-to-one impact on the happiness score of people in general. So let me show you one more example down here. This is a network graph. We're using a library called PyViz. I like this a lot. I've got several videos that explain how this works. So this is pretty interactive. It's pretty cool. It shows you everything that points to happiness score. So the biggest, strongest impact is generosity, 0.96. The smallest would be 0.37, I think, 0.3052. We see that over here, 0.3052, right? And I just like how you can see the score, or not that everything impacts the score. You can see the weighting on each of these features to impact the score, right? When you put the mouse over it, and of course it's dynamic, it's interactive, you can move it around and everything moves relative to whatever node you're moving, right? The node is a circle and the edges are the lines between the circles. So there's one more analysis. I actually already did this above. I think I will delete the first one. I did this a few days ago and I forgot that I had that in there, and then I added it back this morning, but I think this just belongs down here just a little bit. It's a little bit more appropriate to look at these two side by side. So that's good. I'm going to keep all this. Okay, we answered our question. What features impact the target variable, which is score, the most? Okay, and this is what we're looking for: greater than or less than 1.96 in the T column, right? So we see significant, significant, significant. That is significant. These last two are not. We just saw that. And we're looking for a lower p-value. So anything less than 0.05 will make the cut. It's statistically significant. But what's interesting here is we have social support significant, GDP per capita significant, health life expectancy significant, and freedom to make life choices significant. But generosity was actually not significant, right? It didn't make the cut. This has to be greater than 1.96. It's only 0.94, and this has to be less than 0.05. It's at 0.32. So if you use a linear regression model like this, we get a very different outcome than if you use a DoWhy, cause and effect causality approach to answering this question, right? So my original focus was what is the cause and what is the effect, and what's the causal influence here, or the ability of these different features to have an impact on the score variable, which is a happiness variable. But then I also wanted to do a more traditional linear regression model just to see how different it is, and it's actually very different. So you really have to understand what type of problem you're trying to solve and pick the right tool for the job, right? So it's two very powerful models that you're looking at here, but you have to understand what is your end game. If you want to estimate the effect of each treatment individually while controlling for all others, you would use a DoWhy model. So this is the cause and effect, causality, influence, right? If you really want to create a model to train and test and make predictions into the future, that's a very different type of problem that you're trying to solve. And you need a different approach and a totally different model. This is called OLS, ordinary least squares model, okay? So if the goal is to understand which features have the most statistical impact, you would use the causal effect. If you want to say which features can cause happiness, right? If you want to do more of a exploratory analysis and train the test model and make predictions into the future, which countries are most likely to have a high score, then you would use a regression model. Okay, so different approaches to solving different problems. And again, you have to use the right tool for the job. Okay, so that's it. I'm going to wrap it up here. I think the analysis was very thorough. I was kind of surprised that generosity came up number one over here. I did not expect that. I thought it was going to be a little bit more like GDP per capita. It means more money in the country and people will be happier. But the old adage is true. Money can't buy happiness, right? So it's really how generous people are in that culture that will cause happiness for the entire culture to appreciate, and more people will be more happy, and probably that will overflow back into the culture, and you'll create a positive feedback loop where more people are more generous and thus more happy, then they become more generous and become more happy, and so on and so forth. That is my takeaway here, okay? So hopefully you saw that interesting, insightful. Yeah, that's it, guys. I try to do these exercises, learn from it, and drop my knowledge here. When I have my findings all polished up, I showcase that to you guys and share it with y'all. So I'm going to post this code later today. You can download that. Like usual with all the videos, you can download all the code and run it for yourself in your own Jupyter Notebook environment. Hopefully this was interesting and useful to you, and hopefully it was a good use of your time today. So I'm going to wrap it up, and I will see you in the next video. Bye for now.